Good morning, everyone. Today we are going to go through a few practice problems related to arc length. You should have seen the notes already on arc length as your assignment, but now we will do a few practice problems. And so arc length is going to be a really important calculation in a number of places. Up on the screen here, we have a picture of the Earth looking straight down at the North Pole. And what you see is some flight paths. We have a flight path sequence here that I just grabbed off the internet. This is Vancouver, Canada, and the flight going to JFK, which is in New York City Airport, flying over to Hong Kong, and then the last stop here is actually Colombo, which is in Sri Lanka, an island off of India. It's interesting to me just to look at maps like this because we see, first off, each of these paths are an arc length. They are a fraction of the circumference of the Earth. Therefore, the distance is a curve and is not simply a straight line. So in order to calculate the actual distance, we'd be needing to think about what fraction of the circumference or what part of the arc of the Earth are we traveling. And the other thing that I find interesting is as we fly, for instance, from Vancouver over to Asia, oftentimes we'll think about traveling east or west to get in that direction. But in this case, the shortest distance is not really east or west, although there's a component of that. It's actually almost flying over the North Pole to get to the other side of the Earth. So I found that picture was interesting. And look at these distances down at the bottom here. Would all be calculated by using an arc length, a part of the circumference, not just a straight line. So I thought that picture was interesting. Now in front of you, you should have a sheet that is going to look similar to what you guys did in your notes. We're going to do a few of these practice problems together, and all of them are related to arc length. So remember, arc length is basically just taking a circumference calculation and then figuring out what part of the circumference are we looking at. What fraction? Is it 1/4 of the circumference? Is it 1/2 of the circumference? Or is it some other fraction that's maybe just a little bit harder to calculate? As with the other assignments, we're looking at the 4-step process here to help us organize our work. And so let's go ahead and look at problem, well, in your sheet here, it's our first problem. It's problem number 4 from another sheet that I had screenshotted here. So we are going to take a look at this problem over on the left-hand side here. So in that problem, you have to find the length x, y, length of that arc right here. And you're given the radius of that circle as 10 units, and you're giving the degree of the arc measure as 70 degrees. So as with the other problems, we're going to start off with the formula. So I'm going to abbreviate a little bit, but we're going to say something like arc length is the arc measure out of 360 degrees, because that would be the fraction of the circle, times the circumference, which is pi d, or in this case, you're given a radius, which will multiply times 2 to get the diameter. So plugging some numbers in here, we've got arc length is equal to 70 out of 360 times the circumference. So 70 3/60ths of the circumference. Now notice that the radius is 10 units, so the diameter is 20 units. So we got to make sure that we put in the correct number. In step 3 here, we're going to do a little bit of work. So arc length, basically I'm going to reorganize this first and think about, okay, what fraction of the circumference we're looking at here. Let's try to reduce 70 over 360. We can fairly easily reduce that by thinking about 10 goes into 70 7 times, and 10 goes into 360 36 times. And then I'm going to put the 20 next, and then the pi after that. If I'm going to leave my answer as an exact answer in terms of pi, I'm going to go ahead and just multiply this part of it together. 736 times 20. Now when you do that, you can use your calculator if you want. You'll get a repeating decimal. If you're going to reduce the fraction, though, let's just do a little side work just to review. When we were multiplying fractions, what this really is 736 times 20 over 1. And if You want to reduce this fraction. Sometimes it's best to do it before you actually multiply. You could multiply straight across and then reduce from there. But sometimes I like to look diagonally here or vertically. What common factors are there in the numerator and denominator? And you'll notice between the 20 and the 36, 4 is a common factor. 4 goes into 25 times, and 4 goes into 36 9 times. So therefore, when I am multiplying this across, I can do 7 times 5, which would be 35, and 9 times 1, which would be 9, and then pi's off on the side here, and that would be my arc length as an exact answer in units. 35/9 is not really a super nice fraction to look at. Some of you guys are probably bothered just by leaving your answer in terms of pi here at 35/9. Maybe you are liking a decimal version of the fraction just a little bit better. So if I take 35 divided by 9, I get 3.8 repeating pi units for my arc length. And some of you guys are probably still bothered by that. Let's actually multiply that times pi and get a approximated decimal, which is approximately equal to, what, about 12.2 units. So I'm going to give you guys 3 answers on this one that are all the same or relatively the same, because we've got our exact answers up top here, which are leaving your answer in terms of pi, and that's about 12.2 units. So this arc length up here is about 12.2 units. In this case, I'm not giving you centimeters or inches. I don't believe so. We're just going to leave that as units. All right, I've taken up some of my room for number 5 here in the next one, so I'm not going to do that one. But I do want you to notice, if you were calculating the arc length AB, you'd have to be thinking about your inscribed angle formula here. So you'd have to be thinking about this as 80 degrees, and then that 80 degrees would be the arc measure that you would be using to figure out the arc length. Let's skip over to number 6. Pause for a second here, since you guys might be watching this as a class. You might need to just catch up with some of the things that I'm writing or saying here. Okay, so moving on to number 6. We've got now a circumference that's given. So we're given the distance all the way around is 25 pi units, and we're given a central angle of 90 degrees here, which of course means that my arc measure is 90 degrees. Okay, so we're given some different parts in number 6, but we're still going to start off with our formula, which is arc length is fraction of the circumference, so the arc measure out of 360, and the circumference being calculated by pi d. And just like the other problem, we're going to plug in what we know for our second step here. Now in this case, we're plugging in the actual circumference itself up here. So that number, 25 pi, needs to go in the arc length spot. Actually, what am I doing here? That's not correct. So we're given the circumference, and we're calculating the arc length. So that needs to go in the circumference spot, which would be the arc measure out of 360 times 25 pi. Okay? And in that case, we're also given 90 degrees out of 360. So the circumference of 25 pi here, I apologize, my one take here, I plugged it into the arc length spot at first there, but that is not correct. It is the circumference. So that goes in the circumference spot here. Remember, this pi d is just a calculation of the circumference. So it's 93/60ths of the circumference of 25 pi. And so we're going to plug it into that spot. And then additionally, the arc measure is 90 degrees. So we'll put that into the arc measure spot. Okay? Thank you for bearing with me here. So now let's do a little bit of reducing our fractions here. So basically we've got 93/60ths, which is 1/4 of 25 pi. And then if I'm going to be thinking about leaving my answer in terms of pi. I'm going to multiply 25 times 1/4 or 1/4 times 25. Now this is not a fraction that will be able to be reduced here. You'll notice if I'm multiplying 1/4 times 25, there's no common factors of the numerator or denominator. So I will just multiply across here, and that will leave me with 25/4 pi for my arc length AB. And then as a decimal, of course, then if you take 25 divided by 4, that would be 6.25 pi units, by the way, on this case. And if I wanted to get a final rounded answer and multiply through by pi, then I would get, let's see, 6.25 times pi is approximately 19.6 units. All right, so any three of these will work for our answer. The first two are more exact answers, and the last one is the rounded decimal answer, which means I should probably have approximately equal to here. All right, let's go on and do one more problem, maybe on the back side here. I'll clear off what I have, and actually let's do that second one. So I've highlighted that one. It's a little bit hard to read on there, so I've put in the measurements that we need and highlighted in blue and red the other parts of the circle. All right, so this is what I was thinking of the last problem when I was starting it, where we're given something a little bit different. But let's go ahead and write down our formula. So arc length is a part of the circumference, so arc measure out of 360 times pi d. So remember, that is the circumference calculation. All right, let's go into our problem and actually see what we're given. In this case, we're given the arc length, okay? So that's when you actually put that into the arc length spot right here, okay? So the arc length is 14 pi units. All right, arc measure, now be careful with this. 80 degrees is an inscribed angle here. So if we're going to be finding the arc measure here, we have to be thinking about how many degrees that would be. So inscribed angle conjecture says the inscribed angle is half of the arc measure. So we know that right there would be 160 degrees for the arc measure. So 160 out of 360 times pi d. All right, now we are supposed to be calculating the diameter on this problem, so d is what we're going to actually solve for. All right, let's go ahead and now do a little bit of simplifying and then maybe a little bit of algebra as well. So I'm just going to simplify this fraction a little bit. Okay, so if I divide it by 10, I've got 16/36, and then let's see, 4 still goes into 16 and 36. So now I've got 4/9, 16/36, 4 goes into 16 4 times, 4 goes into 36 9 times pi d. Okay, so I've just reduced the fraction. Now I'm going to go ahead and solve for the diameter here. So I'm going to do a little bit of work. This is 4/9 times pi times diameter. So to undo multiplication and work my way backwards to get d by itself, why don't we go ahead and divide both sides by pi? It's kind of nice because that will cancel out pi from both sides of our equation. So now I've got 14 equals 4/9 times d. And then I can think about, okay, if I want to solve for d here, I have a few options. Those of you guys who are good with fractions, what you could do is multiply by the reciprocal here. So multiply both sides by the reciprocal. Or I could take it in 2 steps. I could undo the dividing of 9. Algebraic step here would be to undo dividing by multiplying. So I could multiply both sides by 9 first. And so I've got 9 times 14. So that gives me 126 is equal to 4d. And then I could do my second step here, undo that multiplication by dividing both sides by 4. And so I'm going to divide both sides by 4 here, and I'm going to get D, the diameter, is 31.5 units is equal to my diameter. So in that problem, I end up with 31.5 for the diameter. So you can see some problems you're plugging in numbers on the right side of the equation. Some, like this one, you have to work backwards because you've plugged in something on the left side for the arc length, and then there's an unknown variable over on the right, and you need to use a little bit of algebra to solve for that. The other difficult part is dealing with these fractions because they're not necessarily super nice fractions that we're working with, so there is a little bit of work in review there with getting an exact answer by also using fractions. The other 2 problems here I'm going to leave, and we're not going to do those examples together. You can certainly try on your own, and there's room there to show your 4 steps. Just be careful by looking at what it is asking you, what it is given. Are you solving for a diameter or a radius? Are you solving for the arc measure, or are you solving for the arc length?